Okay. Hi, everyone. Yeah, everyone there? Come on, no one
I'm here.
there. Okay. Should we
Here
get
too.
okay? So are you guys touching mean value theorems this week? Or just the definition of the derivatives of the differentiation?
I think the only thing that we've done is the the definition.
Definition? Okay.
Yeah,
Yeah.
Then we just do some definition problems today's. They're pretty simple, I would say. So I think you guys should do it together. Okay. Okay, let's do it. So you want to use the definition. The first problem, you want to use the definition to find the derivative of square root of x for x greater than or equal to 0. Okay. So what? So first question, what is the definition of the derivatives?
F of x plus h minus f of x over h.
Minus f of x over h. What limit? I would say limit, right?
yeah, the limit as h approaches 0.
Okay. This is f prime of x. What about the second definition, f of I? You have a limit of x approach 8, f of x minus f of a over x minus a. Okay. So this one is, you want to use f prime of a's definition when you try to find the derivative at a specific point. I would say, for example, if you find you want to find derivative at 0, then you're gonna use f prime of 0 equal limit x goes 0 f x minus f of 0 over x minus 0. Okay. Then how are you gonna do this one? F of x equals square root of x greater than or equal to 0. What do you guys think? What do you guys think? Or should we do breakout room? So because I think we just have 2 problems, maybe 3 today's. That's fine.
Fine with me.
Okay, then let me do breakout room. Okay, see you in 10 minutes. Hi. What? Why just you? Okay.
Yes.
What do you think?
So it's the square.
Have square root of x.
Okay. So I think you would use the
First one or the second one?
first one.
Yeah, the first one. Okay. So you're gonna have the limit of f x plus h minus f of x over h equal to
Mhm.
0. This is f prime of x. Okay. This equal to what?
Square root of x plus h.
Okay.
Minus square root of x
Okay.
over h.
Okay.
Second. Hold on 1 second. Then that's equal to, oh gosh. I think that's correct. X plus h, like the square root of x plus h minus x.
Okay.
So, then over h, which is
Okay.
equal to the square root of h over h.
Square root of what? Square root of h over h? How?
I will admit I am a little rusty on square root laws. So
So
I assumed that you could combine the two, so it would be square root of x minus h
no, you cannot.
minus x. Okay.
But
Yeah, I
even-
also had a concussion. I have a concussion right
okay.
now, so I'm a little rusty.
Yeah, it's just
I
so
hit my head pretty hard on Tuesday. So I guess what you would do is,
well, probably you do conjugate, right? Wherever you have fraction,
mhm,
wherever you have fraction, and wherever you have okay, let me.
okay, so it would be, you would multiply the entire equation by x square root of x plus h plus x, right?
Right.
Okay.
Plus square root of x, okay? But when you
Mhm.
multiply, you have to divide as well, right? So it's 1x plus
Yes. Yes.
plus
So
x.
the denominator and the numerator
Okay.
are multiplied by that term, and then you get x plus h minus x, limit as h goes to 0 of x plus h minus x
Okay.
over h times x plus square root of x plus h plus h
Okay.
times the square root of x.
So this one equal to x crossed h
Uh-huh.
over h. This one cross this one as well. So you're gonna have 1 over x plus h plus square root of x. Okay.
Mm-hmm.
Then well, what do you guys think? This one equal to what? No, sorry, h equal to 0.
So as h goes to 0, the limit becomes 1 over square root of x plus square root of x,
Yes.
which is 1 over 2 square roots of x.
Yeah. Yeah, correct, right?
Mm-hmm.
Because the derivative of square root of x is gonna be equal 1 over 2 square root of x.
Mm-hmm.
Okay. Yeah, I think you're right. So you can have a look at the second problem or a second one. Copy. All right, case. Okay, this one fx equal x squared for x greater than 0, and fx equals 0 for x less than 0. So you want to prove f of x is differentiable at x equals 0, and you want to answer this question: is f prime continuous on R, and is f prime continuous? I'm sorry, is S prime differentiable on R, right? Which means if it differentiable on R, then we have f prime 2 prime of x on R, right? So the first thing you want to do is you want to prove fx is differentiable at x equals 0.
Okay.
Okay. Okay. All right. I have to go to different room right now. Okay.
Okay. Thank you.
You're welcome. All right.
What's up, Nat?
So, first question. What do you guys think? Where are the bets?
What?
You want to find derivative of square root of x.
Yeah, with the definition, not a rule, right?
Yeah, of course.
So we thought it would be smart to go with conjugate first.
Yes.
Conjugate.
Oh, yeah.
So you're gonna have square root of x plus h, right? Minus
Yeah.
square root of x over h is equal to 0. Conjugate, then you're gonna have x plus h minus x,
Mm-hmm.
limit x equal to 0. Then this one become h square root of x plus h plus x, sorry, plus square root of x. Yeah, then what next?
What do you have now?
Oh, sorry, I haven't said my
You
screen.
have h over.
Okay, then
Yeah.
what next? What do you think?
Mm.
Wouldn't it end up canceling and going to 1?
Okay, then 1 over x plus h plus square root of x.
Yeah.
equal to
Oh, yo, and then it.
Okay.
Yeah, so that is correct. I just did it wrong.
The same.
okay,
How do you get? Wait, hang on.
x minus x, h over h.
Right.
Okay.
Oh, yeah. I see what's going on here. I am.
Okay,
Howdy, it's late.
then
Plug in.
And then you plug in 0. Yeah. What
Yeah.
you were gonna say, right?
go to what?
It goes to 1 over 2 root x.
Yeah.
Yeah. Okay, pretty easy, right?
Sure.
Right, how about this one?
Which one?
This one? f of x equal x squared, or x greater than 0. F of
Love
x
that.
equals 0. So you want to prove f of x is differentiable
Yep.
at x equals 0, right? So this is picture of it.
Yep. We get that beautiful.
Mm-hmm.
Oh, it's the piecewise. Gotcha.
So you want to prove fx is differentiable at x equals 0, right?
Yeah.
How you gonna do it?
Wouldn't we use the concept of the that it's since it's the limit from the left side is 0 and the limit from the right side is 0,
Right.
since we know that that's true.
So So which means you want to prove f of x is differentiable, which
Yeah.
means you want to prove the limit of this one, fx minus f0
Mm-hmm.
over x minus 0 is existing, right? At x approach 0. So then you can take the limit from the left side and the limit from right side. If it is equal, then we can conclude that f of x is differentiable at x equals 0, right? Yes.
Yeah.
Okay.
So then do it. All right. It's not really obvious. Okay. And remember, you cannot use x squared prime equal to x. Okay. You get the ideas how to do this one or 2a? Yeah.
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 Then can you write it up and so I can have a look at it. Yeah.
Sure. Yeah. Let
Okay.
me.
All right. I have to go back to my room.
For sure.
Okay.
Okay.
Just think about it. We have a lot of time today for 10 minutes. Then if you finish, then do the next one. You're gonna prove
Which is.
continuous or not,
Oh yeah.
and differentiable or not,
Mm-hmm.
whether f prime is continuous or not, or differentiable or not. Okay. Let's just do the first one first, right? Okay. And please write it. Please write it.
Yeah.
Okay.
Yeah.
All right. So what idea do you have, Savannah and Gita, for the second one?
So f is not differentiable on R, right? Because f is not differentiable at 0.
Well, why do you think f? Because the question is f of x, prove f of x is differentiable at x equals 0.
I mean the second one. So f 2 prime x, yeah, it's not differentiable on 0. Am I right?
Yeah, you're right.
Okay.
So but the first thing is, for the first one, how do you do it? How are you gonna do it?
So just apply for the definition at x goes to 0, and then use a limit for fx minus f0 divide
Right,
over.
but the thing is, when you use the limit, right?
Yeah.
You can go from both sides, from the left and from the right, right? But for the left, you have a different f of x, right? And from the right one, you have a different f of x. So f of x from the right one gonna be x squared. From f of x from the left one gonna be equal 0, right? So which one you pick for this one? If you
So I just divide into 2 cases.
right,
Yeah,
it's not really too crazy, because so the first thing you want to do is, hey, you want to look from the left, so you want to put so you want to you want to prove it differentiable at x equals 0, right? Then you want to show that, hey, this limit is exists, right? So limit from at 0 as x approaches 0 is existing. Then it exists when you have limit of x from the left, okay, equal the limit if x approach from the right, okay. So if both of these equal, then we can say, hey, there exists limit when x approach 0. Then and that limit gonna equal this thing. I assume it's a. Okay, you get the ideas?
yeah, I got you.
Okay, so it means you approach from the left and from the right. So let me try it out. So if x go from the left, then limit of this one gonna be 0. Yes, because f of x equals 0 when x less than 0, right? Minus f of 0. What is f of 0? It's 0 as well, right? 0 squared is 0. Then this one is x minus 0, gonna be limit of x go to x approach from the left of 0, then 0 over x gonna be equal 0. What about approach from the right? X equal 0 plus, which means f of x gonna be equal to what? X squared, right? X squared minus 0 squared over x minus 0, right? Then this one gonna become the limit of x go to from the right, approaches from the right, then this one can become x, right? X squared over x is just x. Then this one gonna be equal 0 because x approach 0, which means the limit x go to 0 of f of x minus f of 0 over x minus 0 equal what? Equal 0, because from the left is 0, the limit of this thing is 0. From the right, still 0. Then the limit when x approaches 0 is 0. Then this one, f prime of x is 0 when x equals 0. Yes? You guys get it? Savannah?
Mhm.
Okay.
Yep.
So what about the second question? F prime is continuous? What do you guys think? So we have two equivalent definition. Delta epsilon, right? Delta epsilon definition and sequential criterion, right? So I think in this case we should use sequential criterion, which means if for every sequence expand approach 0, then f of expand approach f of 0. F prime, I'm sorry. F of expand in this case f prime. Okay. All right. What do you guys think? Xn approach 0, then f prime of xn approach f prime of 0, which is 0, right? Because we just prove it. F prime of 0 is 0. So how are you gonna prove it? You wanna prove this question mark right here. What is limit of n go to infinities? F prime of xn. Do you guys think? Equal what? And we want it equal to 0 because we want to prove it continuous. What do you guys think? Remember, we have x sub n go to 0.
So could we have the limit as n goes to infinity of the limit as,
I mean like this?
yes, yeah, as x goes to 0.
Okay. To be x sub n. Okay. Does equal to 0?
I don't,
And you should
I don't
expect
think so.
it equals. You should expect the f prime is continuous. No. Sorry, my bad. No. You shouldn't. Why it is not equal to 0? What do you think?
I mean, if x sub n is going to 0, wouldn't that increase the term, because x sub n is in the denominator?
So, what do you mean by increase that term?
F of x sub n minus f of 0 over x sub n, wouldn't that go to infinity if x sub n is going to 0?
No. We have n go to infinities, which means you have a sequence, right? and go to infinity, which means you have a sequence. The same thing you write the sequence expand, right? Because expand equal and go to infinities. There's nothing special about it, which means we're looking at the limit of a sequence. That's it, right? What do you think, Gita?
I have no idea. I prove it by contradiction.
Prove it by contradiction. Nice. Okay. So you want to prove it because there's no contradiction right here, right? Because so you want to because I just want to ask whether a prime is continuous. So which one you pick? Whether a prime is continuous. So you want to prove it is not discontinuous, then it is continuous. Yeah.
No, I'm not using the sequential definition.
Oh, okay.
I'm sort of wondering to use another definition. I think that will be applied. Yeah, epsilon delta definition.
How about then tell me how you gonna do it.
So so I divided into two cases. One is
So which mean x less than 0, right?
yeah.
X less than delta, right? Because the x of 0 equals 0 right here. Then you're gonna have f of x minus f of 0, right? Less than epsilon, f prime. Okay. Then take 0 minus 0 less than epsilon always. Then we're done with x less than 0. Yes.
Yeah.
What about x greater than or equal to 0? How are you gonna do that?
So yeah. So
Wait. Let me think. How do you divide into two cases? Let me think. I would say you cannot divide into two cases.
Yeah, the idea come into my mind. I'm not sure whether it's correct or not.
Because let's think about what is delta and epsilon meanings. So you know that hey, f prime is continuous everywhere, but we want to prove it is continuous at 0 as well, right? So 0 is our point. Okay. Then if you want to put delta epsilon, then at x0, then you're gonna put a bracket, right? For this one, right? We call it delta, right? So x always less than delta. But the bracket is, if you capture the point 0, then it's gonna be between negative side and positive side. Then you don't know what f of x you have to use, right?
Oh yeah, that's why I'm sort of wondering to use a contradiction. So I assume x n is greater than 0, and there is some point a is less than 0, and I'm sort of wondering to reach a contradiction which says there is a point that a should be greater than 0. Oh, there should be an fx minus f. Yeah.
Right, but
absolutely.
But the answer is f prime continuous at 0. It is? Yeah, it is. It is continuous at 0, right?
Oh, yeah. Maybe
Now,
I'm
let's think about this. So what is f prime of x? F prime of x is going to be equal what? 0 for x less than 0. And 2x for x greater than 0? Yes? If you allowed to use, if we are allowed to use the derivative rules, right? Then when you draw the graph of f prime, this graph of f prime, then should look like this. At the point 0, it's still like this. Do you think this one is discontinuous?
Oh, I got you.
Okay.
Yeah.
Yeah. So you want to prove it's continuous. And I very much believe that you just use sequential criterion. It's much easier, I would say. So everything you need to do is, hey, you want to solve f prime of x sub n equal to 0. And I would say pretty much we already saw it, right? All right. Just have a look at this one. Pretty much we already saw it. Okay. Think about it. Right. I'll be back in your room in just 5 minutes. Let me have a look at the other room. Yeah.
Okay.
Okay. So think about it. How you can solve f prime of x sub n equal to 0. Okay.
Oh, what's up? What's up, Nat?
Well done. All right. What do you guys show me?
For the limit one, or how do we know that it's differentiable at 0?
Whatever you have.
So currently, what I did was I took the limit of the left half as it approached 0.
Okay.
And so we got 0.
Okay.
And then I took the limit of the right half as it approached 0, and we got 0. And then
Okay.
I said, okay, we know that since the limit exists at that point,
Okay.
and it's the same limit, we know that at that point it is continuous and differentiable. Right?
I would say there is. So I would say for question A, yeah, it is f of x is differentiable at x equals 0.
Yes.
How you prove f prime of f is continuous?
F prime of
Yeah.
x?
That the second is talking about the f prime, not
But
f.
wouldn't we be able to do it again? Just take the limits of as both approach 0, get 0, and just say, hey, there we go. Since it's the same number, we know that it's that the number itself is contained within both sets as the sets include, or as the sets approach 0. Therefore, they are not partitions and overlap at 0. Therefore, it is continuous. Can we do that? Would we be able to do that?
So for f prime is continuous, let me share my screen. For
Yeah.
f prime is continuous,
Yeah.
So to prove continuous, you have two things:
Yep.
delta epsilon definition
Mm-hmm.
and sequential criterion.
Yeah.
So for sequential criterion, for all x sub n go to 0, then you want to prove f prime of x sub n go to f prime of 0 as well, which is 0 in this case, right? Which is right here. So we should want, hey, this is let x sub n go to 0.
Yeah.
Then how you gonna prove f prime of x sub n go to 0? What do you think?
Would we show that it's
What do you think? What do you think?
Do we have to do the Lipschitz? The Lipschitz?
Why Lipschitz?
I don't know. I just
Okay,
we do-
yeah, Lipschitz, okay.
Could
But
we do any
remember-
form of continuity?
Remember, so remember, not every function is Lipschitz continuous,
Yeah.
right?
This one would be though, right?
I'm not sure, but so you want to prove, for examples, not every continuous function is Lipschitz.
Yes,
Yeah. Yeah.
but every Lipschitz continuous is continuous.
Is not only continuous but also uniformly continuous.
Yes.
Right. So, but the thing is, you want to add prime of x continuous at x equals 0, right?
Yeah.
Because pretty much on R is pretty much continuous, right?
Yeah.
So the
yeah.
point is just x equals 0. So you want to prove continuous at x equals 0? And do
Mhm.
you think we have derivatives of f prime, which is f prime prime at x equals 0?
I know that the derivative exists.
Really?
Yeah, it's 2.
So what is f prime of x? 2x, right? X
Yes,
equals 0?
2x, and then it'd be 0.
0, right?
Yeah.
Then how are you gonna draw the graph of that one? It should be look like this, right?
It's a line, yeah, and then it goes up at a straight line. Yeah.
Right. And do you think at a kint we have derivative at x equals 0?
Oh, because it's not a smooth curve, is it?
Right. So at a kint, do you think we have derivatives? I don't think so.
Oh, yeah.
It's not differentiable at x equals 0, but it is continuous at x equals 0.
Yeah, that's what it was. Yep.
So I want you guys to prove, hey, how can we prove at prime of x sub n equal to 0? That's all we need to do.
Wouldn't we just take the limit?
Yeah, we are taking the limit right now.
Yeah.
Okay, what do you guys think? What do you guys think? And I would say we pretty much do this thing at this one, right?
Mm-hmm.
So you have limit of n go to infinity, of limit f prime of x sub n, right? F prime, what is the definition? X n go to 0? Yes?
Yeah.
Of x sub n minus f of 0,
Yeah, wouldn't it?
x go to 0.
Yeah.
So do you think this one go to 0? Pretty much this thing and this thing, it's just the same thing,
Yeah. Yeah.
right? So
Yeah.
at this one, you are also looking at, hey, for every x of x sub sequence x sub n approaches 0, right?
Mm-hmm.
In this one, you do the same thing. For every sequence x sub n approach 0. Yes?
Yeah.
Then because this one equals 0. Right? Because
Yeah.
this one go to 0, then this one must be go to 0. Must be going to 0. Yeah?
Yeah.
What about f prime is not differentiable at x equals 0. All right, what do you guys think about this one?
Wouldn't you say it's not?
Yeah, it is not differentiable at x equals 0.
Yeah.
So we pretty much do the same thing as the first part of this problem.
Yeah.
Right?
Yeah.
So we evaluate from the left, from the right, to see
Mhm.
whether it's 0 or not. Yes? Okay.
Mm-hmm.
So assume we find out that x squared equal to x f prime. Okay. Then you want to have f prime of x equal what?
Yeah.
2,
It's
0?
2 and 0, which means it wouldn't be continuous. That wouldn't be continuous.
Like a German discontinuities.
Yeah.
Prime. But we don't have this thing yet. And I want you guys to prove it by definition. Okay? Okay? You guys get it?
Yeah.
All right. So write up, please, write up.
So I have the definition proof there, where the limit definition proof for x for the derivative of 2x equaling 2. What should I do after that, if anything?
Okay. Then can you write up so I can have a look at it? I'll be back in a second.
Sure.
Yes, okay. Okay, let me take a look at this one. Nope, not precision. Okay. Hey, what do you guys think?
I was stuck. I'm not really sure.
Oh, okay. So in general, we have this thing, right? Limit of n go to infinity, limit of x of n go to 0, f of x of n minus f of 0 over x minus 0, right?
Mm-hmm.
So do you think this one, sorry, this one right here and this one right here is similar?
Yep. Yes, definitely.
Because if a limit of x go to 0, which means you're looking at the sequence of x approaches 0, right? This is the same thing. A sequence of x approaches 0, right? And because if something, then it's going to be equal to 0. Okay?
Mm-hmm.
Yeah, pretty much very easy. So what if, even we don't know that, what if we take f from the left and from the right? How about that? Right? From the left, we have limit of f prime of x of n. Always, because this one always equal to 0 and go to 0. Then this one is equal to 0, right? F prime okay, yes. For every sequence x of n approach 0 prime. How about from the right? If limit of n go to infinity, f prime of x of n. Okay. Assume we know the derivative rules, then f prime of x of n going to be equal to f x of n. right? And go to infinity. Then you have 2 limit of x, f of x band and go to infinity. F of x band can be x squared. And this one equal to 0. 2 times 0 equals 0. Yes?
Where did the 2 come from?
Assume we know the derivative rules. Right?
Ah, yes. Okay. Okay.
No, wait, let me think. F prime of x band should be 2x band, sorry. 2x band, right?
Yeah.
Limit of n go to infinities. 2x band, because x band go to 0,
Mm-hmm.
and this one equal to 0, right? Okay. What about the next question? I think I'm gonna bring everyone together. Right. So everyone knows how to prove f prime continuous at x equals 0? Yeah? Right? You guys get it?
Yeah.
Okay. Then how you wanna approach f prime is not differentiable at x equals 0. What do you guys think? So we pretty much do the same thing, but this time we do it for f prime. So what about you have limit of x go to from the right, approach 0 from right, f prime of x, all right, minus f of 0 over, sorry, f prime of 0, x minus 0, right? This one gonna be equal to the limit of x go to 0, approach 0, sorry. F prime of x when x, f prime of 0 gonna be equal to 0. We just prove it, right? We just prove it right here. Then f prime of x when x approach 0 from the right, which means 2x over x minus 0. This one is limit of x approach from the right of 0. 2x over x gonna be equal to what? 2x over x. Then this is gonna be equal to 2. Yeah.
Yeah.
Then limit of x go to x approaches 0 from the left. F prime of x minus f prime of 0. X minus 0. Okay. F prime of x when x approach from the left of 0 gonna be equal to 0, right?
Yeah.
0 minus 0 over x minus 0. Limit of x approach 0 from the left. Gonna be equal to limit f 0 over x. Then we can, when x approach 0 from left, we can divide, because this one in, which means x approaches 0 but not 0. Okay, which means you can divide 0 by something very close to 0, and it's going to be equal 0. So then there's the limit of x go to 0 of f prime of x minus f prime of 0 over x minus 0 does not exist, which means we don't have the f2 prime of x at x equal to 0. Yes? Everyone get it?
So you're saying that if we get a 0, it's not differentiable, right?
For f prime?
Yeah. Well,
Yeah.
if we get a 0 in f prime x minus f prime 0 over x minus 0, if that, as sort of a general statement, if that equals 0, then
You mean this one equals 0?
yeah, that's what you just said, right?
So I just said f prime is not differentiable, because
Yeah.
the limit of this one does not exist when x approach 0, right? Okay.
It's like limit from both sides, like from right and left.
Right, from right and left. And you can see, you can draw the graph of f2 prime of x, right? Can be equal to 2 if x greater than 0, 0,
Yeah.
x less than 0. Then you're gonna have a jump discontinuity right here,
Yeah.
right? This one a jump. Then I don't think you can differentiate at x equals 0.
Yeah.
Okay. So you guys have any question?
Yeah, I got, it might be like a, how did you get, like, when you take the limit from left, you got f prime of x equals 0?
This one?
Yeah.
Because
0.
f prime of, because of this thing, right? This one. Oh, this one is plus. This one's no. This one plus. Yeah. Where's minus 1? Where did you put a minus? Wait. This minus. Yeah. Because we have this thing right here, right?
Okay.
So you have the limit of x approach the left side, which means when x less than 0, right?
Okay.
then f prime of x equals 0. Yes?
Yeah, yeah.
Okay. Just prove it. F prime of x is equal to 0. Okay? Yeah, get it?
Yes.
Any question? So I would say in general, you want to find the f prime. If you do it, so you need to find where that's one. You find f prime of x equal 2x if x greater than or equal to 0, and 0 if x less than 0. Okay? Just
Yeah.
find this one. This one is pretty easy, right? You have x squared minus a squared over x minus a, which means x plus a, right? Then limit of x plus a when x go to a gonna be equal to a, right? Then f prime of x gonna be 2x if x greater than or equal to 0. Then because it's constant, then this one should be easy as well, right? When x less than 0. Okay? You guys have any question? Question? No?
No.
All right. So what do you guys think? We just go over just 2 problems today, but we have more time for you to do the problem? Or you want, we have 3 or 4 problems, maybe 3, then I go over all of them by myself.
The second option, like
You-
when we have like too many problems and
So you want, we have 2 problems and you guys can work on it?
oh no, I mean like we have like a bunch of problems, like more problems, and you're gonna solve it.
Yeah.
From my opinion.
Okay.
It might help to have a to have sort of a here's how you should approach problems that are structured this way.
Right, but the thing is, then I cannot do breakout room with 3 problems because that's too much, right?
We don't do like breakout rooms.
So then you guys want me to like throw the problems, then I'm gonna solve it?
I don't know. For my opinion,
Yeah, it's
if
fine.
I don't know.
Yeah, just fine. Yeah. Okay. Then I stick to the old way rather than just 2 problems. That's fine.
Sure.
Okay. All right, next week. So I think you guys almost finished the semester. I think you guys just need to learn mean value theorem, some
Yeah.
fundamental theorem of calculus, but I would say he just mentioned it rather than actually put it on the exam. So which means
Oh.
your semester gonna be ended at mean value theorem.
Gotcha.
Maybe next week.
Okay.
Okay. I'm pretty much sure about that. Okay.
Thank you.
Okay, thank you.
Thank you so much.
Thank
Yeah.
you. I think you have a good day. Okay, good night.
You too.
Thank you.